Good evening. Today we are going to see the trusses and its different elements or its different parts. So truss and its elements. So now we have trusses actually large column free areas are required for auditorium, assembly halls, workshop, etc. For such a requirement, truss is the commonly used structure. Means where we require large column free area, there we are going to use these trusses. In this type of structure, a set of trusses are interconnected by purlins. So two trusses are connected by purlins, and these purlins supports the sheet. Means two trusses connected by purlins and also supports the sheet, that is roofing material. These trusses are supported by walls or columns. As triangle is the primary pin jointed stable frame, so that all trusses are preferably comprises of triangular figures. So if you will see any truss, then you will see it is comprises of triangles. So now we will have different elements for this. So now we have this will be support. So we may have column below it. Now I am going to say this as a support, and we have column below it. So now we have this as support. Now on this support, we have clit. So you can see we have this is a clit, and this clit connects the members of the trusses. So now we will see one by one elements. So now we have first principal rafter. Now this principal rafter will act as compression member for dead load and live load, and it will act as tension member for wind load. Then we have main tie. Now this red line you can see we have, that is centroidal line of the angle section. So main tie, again this is tension member for dead load and live load, and it is compression member for wind load. Because dead load and live load act in downward direction, whereas wind load act perpendicular to the principal rafters. Means load is perpendicular to the principal rafters. Then we have this as gusset plate. Now this gusset plate we are going to use to connect the members at that joint. So these are bolts. So we have these as bolts. And this is connected over here to the cleat of the angle. So we have this as gusset plate used to connect the members at that joint. Then we have this gusset plate. Now we have to keep in mind we have centroid of all. So if we will draw centroid line of this, so we have in this fashion centroid line of this. So we have centroidal line of this. So where this will meet, generally we have purlin on this and load will act at this. So whenever load will act at this joint, then our members will act as axial members. So centroid of all members we have at this. Now this gusset plate you can see we are using to connect all the members. Now here you can see this is perpendicular to this angle. Now this is perpendicular to this angle. Generally, the plate at the angle is perpendicular to the member. So we are in this fashion. So now we have this also, we have gusset plate, then we have these members. So we have gusset plate member. You can see on left of this, we have members. That is our thickness on right side. So centroid we have in this way. This is always close to the outstanding leg. Already we have seen in the class. So now we have this as purlin. Now already we have seen purlin we are going to use to connect two members, sorry, two trusses, or and it also supports the roofing material. Now we have this purlin, and this purlin we do not have any connection with the principal rafter, and to make the connection we are going to provide another angle, and these angles we are going to connect by bolts. So this angle which is used to connect purlins to the principal rafter is also known as clit angle. So this clit angle is used to connect purlins to the principal rafters. Now we can have these purlins. These are at the joint where we have different members meeting. So you can see we have purlins that is exactly at the CJ of this. So load will act at the joint and members will act as axial members. So we can have purlins at all the joints. So we have these are purlins along with clits. Now we have this as roofing material. Now we can see roofing material. This is supported by these purlins. So purlins are used to support the roofing material and to connect the two trusses. So now we have this as roofing sheet or roofing material. Then we have this as a ridge, and this ridge we are going to use, or we are going to use this to connect material on two sloping sides. So we have this also roofing material, and to connect this we are going to use a ridge. Also, to avoid the leakage due to rain, we are going to use this ridge so that water will leakage over here. So it may go like this. So till this, and it also comes in this fashion. So we have roofing material till this, it may touch each other also. So these are the different members mainly we require in our trusses. So now you can see, now I am showing members on right side. These are exactly opposite. So you can see we have centroid on this side. So members you can see, just see. So we have on this side, we have here on this side, that is centroid. Now vertical you can understand easily. For this vertical, we have inclined it on this, on perpendicular to this, and we have centroid. And here we have not drawn in the same fashion. We have not drawn in this way. So we have here opposite side. Our outstanding leg is on opposite side, so that our centroid CG of the total weight of the truss, that will be at center. So you can see on half side we have centroid, that is on right side, and half side we have on left side. So that centroid total weight will act at centroid of the truss, and therefore we have to put it on opposite faces. So likewise we have to go for the different parts or different elements of the trusses, and that you have to draw in your sheet. So now we will stop here only. So thank you.